This video is solving rational equations. So when solving rational equations, one thing we have to be careful of is the fact that our variable can be, and most of the time is, in the denominator. And for that we have these red flags that we have. And these are excluded values, which are the numbers that would make your denominator equal 0. If when you solve you get one of those excluded values, that's called the extraneous solution. So we're going to look at some examples that include that today. So on our quiz review for section 6.3 to 6.4 quiz review, I'm going to start by looking at number 10. And in number 10, our equation is 3 over x minus 6, and that's equal to 5x minus 2 over x plus 4. Okay, so in order to solve rational equations, it's fairly similar to adding and subtracting rational expressions, and that is the fact that we have to have common denominators. What we're going to do is, let's take a look at something very simple, like 3 over 4 is equal to x over 4. So in this very simple equation, I have two fractions that are equal. I have fraction equals fraction. Since they are equal, 4 is the exact same thing as 4, so that means that my numerators have to be equal, which tells me that 3 equals x. So in rational equations, if we have a single fraction equaling a single fraction, and we have our denominators looking the same, well then we can assume that the numerators are going to be the same. So then what we can do is kind of drop the denominators and focus on the numerators and solving for x. So the first thing you need to do is figure out what is your common denominator. And in order to figure out your common denominator, you're going to have to factor. In this example, we don't have to factor. This denominator is x minus 6. This denominator is x plus 4. You can't factor either of those. So your common denominator is then the combination of both of those factors. So to make your fractions have the same denominators, you are going to multiply tops and bottoms to make them look the same. So the fraction on the left has the x minus 6. It's missing the x plus 4, so you multiply top and bottom by x plus 4. The fraction on the right has the x plus 4, but it's missing the x minus 6, so multiply top and bottom by x minus 6. Okay, so just like with adding and subtracting, you're going to keep your denominators as factors. There's no reason to multiply those out, but you have to multiply your numerator. So distributing the 3, we have 3x plus 12 equals. The right side then we have x plus 4 times x minus 6, and then multiplying out the numerator, you have 5x squared, and then 5x times a negative 6x. Let's write this over here, it would be negative 30x, and then negative 2 times x would be negative 2x. Combining those together gives us negative 32x, and then negative 2 times negative 6 gives us positive 12. Okay, before I go any further, I kind of skipped over this whole red flag situation. So red flag is something you need to do before you even start solving anything. And that is identifying the values that x cannot equal. So if you look at what your denominator is between both fractions, look at each factor and what value of x would make this factor equal to 0, and that would be if x were to equal 6. And what value of x would make this factor equal to 0, and that would be if x were to equal negative 4. So in other words, x cannot equal those because you cannot have 0 in the denominator. Okay, so back to the problem, we have these two fractions. I have one single fraction equaling another single fraction. They are equal. The denominators are equal, which means that your numerators must be equal. So we're going to kind of drop our denominators and only deal with our numerators. Okay. So now we're looking at this equation, and this is a quadratic. A quadratic equation is anytime you have an x squared and an x, which we have that we have an x squared and an x. When you have a quadratic equation, what you need to do is get everything on one side and have it equal 0. Okay? Now you can have it equal 0 on the right side, or you can have 0 equals on the left side. Doesn't matter what side, but everything needs to equal 0. So I have more stuff on the right side, so it's going to be easier if I move my values from the left over to the right. So I'm going to subtract the 3x over and subtract the 12 over. Goodbye, goodbye. So now I just have 0 over there. 0 equals 5x squared minus 35x. And I needed to subtract that 12 there. And that actually equals 0. So now I have 0 equals 5x squared minus 35x, which looks a little bit different from this one because there's no c value. But it's actually going to be very easy to solve this now by factoring, because I have two terms and there is a GCF in there. So if we factor out the 5x, what you have left over is x minus 7. And when you factor, you have two things that are multiplying together to equal 0, which means that each one of those is going to equal 0. So you set each factor equal to 0, oops, and then you solve. So on the left here, dividing both sides by 5, you get that x equals 0. And adding 7, you get that x equals 7. Now before I say, hey, here's my solution, I double check that it's not one of my red flag values, and it's not. So this problem has two solutions. We have a solution at x equals 0 and at x equals 7. So this is one example of solving rational equations. When you are done, you can always take both of these and plug it back into your original equation wherever you see an x, and you should get two equal fractions.